So convolution on color image. We have seen how to perform convolution operation on a grayscale image. So grayscale image can be represented by using this matrix where each cell in the matrix is a pixel value of the grayscale image. And these pixel values can be numbers like this, right? So each pixel can be represented by using only one value, right? So in case of colored image, if this is a colored image, now a pixel in the colored image has three components. If I take out this pixel, this has three components: red component, green component, and blue component. That means in order to represent this pixel, I need three values, right? So that means let's say for representing red values of all the pixels, I will use a matrix like this. This matrix will represent all the values, all the red values or red component of all the pixels in this image. This is red, right? For storing green component of all the pixels in this image, I'll need one more matrix, right? Green, right? So this will store only green values of all the pixels in this image. And for storing blue component, I'll need one more matrix like this. Right? So this will store only blue component of all the pixels in this image. So that means this colored image can be thought of the combination of three images: red, green, and blue. So if I combine these three components of this color image, I'll get a tensor like this. I'll get a tensor like this, or I'll get a 3D component or 3D image. This is red, this is green, and this is blue. So if I put these three components together, I'll get a 3D tensor or cuboid like structure, right? It's a cuboid. So this, if the size of the image is n by n, so this will be n by 3, because there are three components here, right? R, G, and blue. So this is a 3D cuboid we will get for the colored image. Now these three components of the colored image are called as channels. There are three channels here, right? So now how do we perform convolution operation on this, right? So in order to perform convolution operation on this, let's see how to perform convolution operation. Now let's say I have this 3D image, 3D representation of the image. This is the cuboid which I get for the image. So this is n cross c. C for 3, this c is 3 in this case. So this is convolution operation. Now in order to perform convolution operation on this image, I'll require a kernel which is also 3D kernel, right? So if this is a kernel, so this kernel I'll require here. So this kernel will be again k by c. So this c should match with this c, right? Because I'm going to place this kernel on this image, right? So how will I place this kernel? Like I'll place it like this. Let me change the color. Okay, so I'll place it like this. I'll place this kernel like this, and I'll place this kernel like this on this image, and then I'm going to perform element-wise multiplication. This element here will be multiplied with this element here, then this element here will be multiplied with this element here, and what will be the output? The output will be a two-dimensional image, right? because the value here is the outcome of this kernel convolved with this portion or this section of this image, this will yield only one value. This will yield only one value, and that we are going to place it here, right? So similarly, then I'll slide this kernel by one if the stride is 1, and I'll get this value, right? So the image which I will be getting is of size, it will be a two-dimensional image, and the size of the image will be n minus k plus 1 by n minus k plus 1 by 1, because we'll be having only one channel. It will be a two-dimensional image, assuming there is no padding and stride is 1. So though you convolve 3D image or colored image, you will get a 2D image as the output.